the modern application of robotic technology in automotive manufacturing.
But before we start, please support us by pressing like and subscribe buttons. Also turn on the bell notification to get the latest updates. Your support means a lot to us. Thank you.
In the dynamic landscape of automotive manufacturing, technological advancements have played a pivotal role in shaping the efficiency, precision, and safety of production processes. Among these innovations, the integration of robotic technology stands out as a transformative force, revolutionizing the way automobiles are assembled. In today's modern automotive factories, robots have become indispensable assets, streamlining operations and enhancing the quality of vehicles produced. Increased efficiency and precision. Robotic technology has significantly improved the efficiency of automotive manufacturing processes. Robots are capable of performing repetitive tasks with unparalleled speed and accuracy, leading to higher production rates and reduced cycle times. In the assembly line, robots handle various operations such as welding, painting, and assembly with precision, ensuring consistency and quality across every vehicle produced. Moreover, robots can operate 24/7 without fatigue or breaks, optimizing the utilization of resources and maximizing productivity. This continuous operation minimizes downtime and enables manufacturers to meet the ever-growing demand for automobiles in a competitive market.
Enhanced safety.
Safety is a paramount concern in automotive manufacturing facilities, where workers are exposed to hazardous conditions and heavy machinery. The integration of robotic technology has significantly improved workplace safety by automating high-risk tasks and minimizing human involvement in dangerous environments. Robots are equipped with advanced sensors and intelligent algorithms that enable them to navigate complex surroundings and interact safely with human workers. Collaborative robots, or cobots, work alongside human operators, offering assistance in tasks that require dexterity and precision while ensuring the safety of those working nearby.
Flexibility and adaptability. One of the key advantages of robotic technology in modern automotive manufacturing is its flexibility and adaptability.
Unlike traditional fixed automation systems, modern robots are highly programmable and can be easily reconfigured to accommodate changes in production requirements or product designs. This flexibility allows manufacturers to swiftly introduce new vehicle models, implement design modifications, or adjust production volumes without significant retooling or reprogramming efforts. As a result, automotive companies can respond quickly to market demands and maintain a competitive edge in a rapidly evolving industry.
Integration of artificial intelligence.
The integration of artificial intelligence, AI, has further enhanced the capabilities of robotic systems in automotive manufacturing. AI-powered robots can analyze vast amounts of data in real time, allowing for predictive maintenance, quality control, and process optimization. Machine learning algorithms enable robots to continuously improve their performance by identifying patterns, optimizing workflows, and minimizing errors. This intelligent automation not only increases efficiency and reliability but also enables manufacturers to achieve higher levels of customization and personalization in their products.
Conclusion.
In conclusion, the utilization of robotic technology has revolutionized modern automotive manufacturing, driving unprecedented levels of efficiency, safety, and flexibility in production processes. From assembly line operations to quality control and maintenance, robots have become indispensable assets for automotive companies seeking to stay ahead in a competitive market. Looking ahead, advancements in robotics, artificial intelligence, and automation will continue to redefine the automotive manufacturing landscape, ushering in an era of innovation and transformation. By embracing these technologies, manufacturers can unlock new opportunities for growth, sustainability, and excellence in the production of automobiles. Robots play a critical role in the car manufacturing industry, performing a wide range of tasks across various stages of the production process.
Here are some key ways in which robots are used.
1. Welding. Robots are extensively used for welding tasks in car manufacturing. They precisely join metal components together to form the body and chassis of vehicles.
Robotic welding ensures consistent quality, strong welds, and high-speed production.
2. Assembly. Robots are employed to assemble various components of the vehicle, such as engines, transmissions, doors, and interiors. They use their dexterity and accuracy to install parts quickly and efficiently, contributing to the overall speed and precision of assembly lines.
3. Painting. Robotic painting systems are utilized to apply paint to car bodies with precision and uniformity.
These robots can control the thickness and coverage of the paint layer, resulting in a flawless finish while minimizing waste. For handling and material transport, robots are responsible for moving materials and components throughout the manufacturing facility. They load and unload parts from conveyor belts, transport them between workstations, and deliver them to assembly lines or storage areas. 5. Quality inspection. Vision systems and sensors mounted on robots are used for quality inspection purposes. These systems can detect defects, irregularities, or deviations in parts or assemblies, ensuring that only high-quality components are used in the final product. 6. Sealing and adhesive application. Robots are employed to apply sealants, adhesives, and other bonding agents to car components.
They ensure precise and uniform application, enhancing the structural integrity and longevity of the vehicle.
7. Testing and quality control. Robots are involved in conducting various tests and inspections on finished vehicles to ensure they meet quality standards and regulatory requirements. They may perform functional tests, emissions testing, and other evaluations to verify performance and safety. 8. Maintenance and repair. Robots are increasingly used for maintenance tasks, such as equipment servicing, part replacement, and troubleshooting. Predictive maintenance algorithms help identify potential issues before they escalate, minimizing downtime and optimizing production efficiency. Overall, robots play a crucial role in streamlining production processes, improving quality, and increasing efficiency in the car manufacturing industry. Their versatility, precision, and reliability make them indispensable assets for automakers seeking to stay competitive in a rapidly evolving market. Car factories began integrating robots into their production processes in the early 1960s. The General Motors, GM, manufacturing plant in Trenton, New Jersey, is often credited with being the first automotive factory to use industrial robots in 1961. These early robots were primarily employed for tasks such as welding and painting, aimed at improving efficiency and consistency in manufacturing operations. The use of robots in car manufacturing gained momentum throughout the 1970s and 1980s as advancements in technology and automation made robots more capable and cost-effective. Japanese automakers, particularly Toyota and Honda, played a significant role in popularizing robotic automation in the automotive industry during this period.
Thanks for watching. Drop a like, leave a comment, and don't forget to subscribe to watch more videos like this.